Alright guys, let's do number 9. In a local bar, a customer slides an empty beer mug down the counter to refill. The bartender and is momentarily distracted, does not see the mug, which slides off the counter and strikes the floor 1.4 meter at the from the base. Alright, so let me draw this. So you have a beer mug and it slides off. So this beer mug is going to move at some speed, and it slides off from this point 1.4 meters off the base, and the height is that. So I'm going to write the whole thing as the variable. So this is going to be the height, and this is the base. So it's going to have an initial velocity in that component. So just imagine this as sliding off and then hitting the point D, where that is. So let me write the variables there. So the height here is going to be 1.4 meters. And the base here, which I'm going to call distance D, is going to be 1.4 meters. All right. And the height is 0.860 meters. What is the direction of the mug's velocity just before it hits the floor? So I encourage you guys to pause this video and to give this problem a shot. Basically, the problem is really just finding setting up those equations. So L is going to be some point that's going to have I guess I'll use my notation here, X and Y. That's the point. So wherever X is or wherever Y is, and Y, the position for Y is really some initial height plus the initial velocity in the Y component, which is 0, minus simply gt squared over 2. So it's really just that equation. And the position for X is really just some velocity in the X component times time. So it's really that simple, folks. This is literally just the setup, what they want. And notice that the only component that we don't know is the velocity that it slides off. So because X is D, Y is it's just going to be 0. So let me solve for T. So T here, we're going to use this equation. Solve for T. T equals X over the final velocity. And then we're going to plug it in there. So we're going to say that Y equals H minus G over 2. Final distance over the divided by the final is the time it takes. So we're going to clean this up a bit. So we're going to say that Y equals H minus G over 2 V naught square X square. And we're going to multiply by V naught and then solve for that. So V naught is ultimately going to be, so this is going to ultimately be, so X times the square root of G over 2 over the course of H minus Y. So this is basically going to be the whole equation right there. This is going to be the whole answer for the final velocity. So once you put this equation here, let's get the final velocity. So the final velocity of this component is going to be 1.40 meters over 9.8 meters per second squared divided by 2 over the difference between the height, which is going to be Y is just going to be 0. So that's just going to be 1.40 meters. And the unit should match itself out. So, but it doesn't. This would have seconds in the, yeah, so it does match. Okay. So we're going to put this in the calculator, folks. We're going to put X as 1.40. We're going to put Y as 0.860. It's like I like to store it. Doesn't really matter how you guys store this. And we're going to put the whole thing. So we're going to put the square root of G over 2 Gx squared divided by 2 times the Y. And the final velocity here is going to be, for part A, it's going to be 3.34 meters per second. All right, folks, let's answer for part B. What is the final velocity or with in the direction that the max velocity just before it hits the floor. So the final velocity is going to be, I'm going to define this to be Vx and Vy. Vx or V naught is going to be Vx. Vy is going to be the final velocity, which is going to be the initial velocity minus gt. So I'll just put that. And I have to take that negative into the account. All right, so the final velocity is when y is 0. So we're going to use this equation. We're going to find the time it takes for it to hit the floor. And we're going to chuck it in there. So the final time for it to hit the floor is 2h divided by g, square root that thing. There you go, beautiful. 2, we're going to put that there. And therefore, there's your Vx and Vy. So therefore, the final, so the tangent of that direction that this final velocity will hit, whatever that component happens to be, so that's going to be Vx and Vy is Vy over Vx. If you're going to define that to be the angle, it's really just well, it's just plugging in the final for V naught there, and then the gx, or in this case, ignoring the magnitude there, g over the square root of 2h over g. Or in this case, if you want to simplify this, g over the square root of 2h over g, or in this case, the square root of 2gh. There we go. So we're going to put that in there, 2gh, the 2gy divided by vx, presuming I did store it, which I don't think I did, so let me store that first before I do any of the... Here we go. So, let me see. The final minus extra. Okay, so we're going to take tan inverse of that, and the angle that I got for the final component of that velocity, presume we're going to call this downward, is going to be 24.6 degrees. And I think that's the answer for that. I'm not sure though. Alright guys, so once you get your answer, your theta is going to be 309.1 degrees, or in this case, negative 50.9 degrees if you guys want to write it that way. So I hope this guys helps you. Anyways, alright, enjoy.